Hello and welcome to Emergency R, where the goal is to get you going with your data as fast as possible. This video will cover reading spreadsheet-like data that you may not necessarily have imported from spreadsheet software like Excel, but it's data that has rows and columns in it. And for whatever reason you don't want to manipulate it in spreadsheet software, either it's just too big or it's some sort of machine-produced format where you don't really want to have to mess with it before you read it in. So the first thing I'm going to do is set up a project for this demonstration. So I went to File, New Project, and I'm going to make a new directory and a new project, and then let's call this reading I'll call it VCF because I have a VCF file for demonstration, and then you can just decide where you want to put this. Let's see. For me, I have a folder for this programming tutorial, so I'll put it in there. Okay. And then if you go into the description, I have a link to this web page where I have an example file we can download. This is just a dummy file from a piece of software that I created. So I'm not stealing it from anyone if I'm using my own stuff. But anyway, you can follow this link in the description and then go to download. And let's do save as. And then I am going to find that folder that I just made for the project and save it there. Or if it went into your downloads folder, open up your downloads folder and move it into your project folder. So now if I go back into RStudio, I can see that listed in my files. So now that I've got the data file, I'm going to create a script that will contain all of my code for reading that file. So go to File, New File, and then RScript. So this is a text editor here in the upper left, and that's where we're going to be writing our commands for R. So first, because I don't want to have to repeatedly type the name of this file, I'm going to call it something called my file. And then I'm going to make a less than sign and then a minus sign. And we call that the assignment operator in R, and basically it will put some value into a variable name. So then I'm going to make quotes and I'm going to type the name of the file, msi01 genes.vcf. And I hit Control plus Enter to run that. So wherever your blinking cursor is, if you hit the Control key and the Enter key, it will run that line. Now I see that line was run down there. It was run twice because I was demonstrating it. Alternatively, you can press Run up here. And if I look over on the upper right, now I see that this is something that's in what's called my environment. So I have this value in my file that points to this name of a file. Okay, and then I want to do a little preview. You may have kind of a preview of the file if you were also using Chrome, but if you were using a different browser, perhaps not. So, or if you know how to use Bash already, you might want to use the less command to look at it. Otherwise, let's use something called read lines. I'm going to put in my file. And then let's say I want to look at the first 12 lines of the file. And just to make it look a little bit prettier, I'm going to use a function called cat, and then a parentheses after that before read lines, and then after the closing parentheses for read lines, a comma, and then SEP equals quote, and then \n, which will put a new line after each of these. So if I do that, I get a printout of the first 12 lines, which are actually all header lines here. Let's look at 15. Right, so then I'll just click this to minimize this, and we can get a preview of what's in here. So it's all tab delimited. Right, and then if I go up far enough, I see that these were a bunch of column headers up here. So these, in this case, these are the names of different plants, and down here in the table is stuff representing the genotypes for those plants. And if I scroll up, then I have the beginning of the row of column headers with things like chromosome and position and other information. So this is some genetic data. All right, and I can see exactly how many rows I had. So how many header lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. And in fact, yeah, if I look at the first 12, again, that goes down to config, and then if I look at first 13, then that gets to my header, and then 14 is where the table starts. Now you might notice this script is called untitled, so since I've already started writing some code and I'd like to save that, I'm going to save it, which of course you can do with Control S like normal. There's also a little save button. So I'm going to call it, let's say, reading demo.r. You can name it anything as long as you end it with the .r extension. All right, and now I see that it has a name, and then once I edit it, the save button will light up again so I can save any changes that I've made. Now, another thing I might want to do is explain to myself why I'm doing certain things. So say I insert a line here, I'm going to type the pound sign, and then I'm going to make what's called a comment to describe what I'm doing. And I can do that here as well. And maybe I even want to add a title overall for what I'm doing. So when I previewed the file, all I was doing was printing out the data. I wasn't really importing it into my R environment. You see that data doesn't appear anywhere over here. So the command that I'm going to use for reading the data is called read.table. And I am going to look at the help page for this function. Because this is such a custom format, I'm going to have to do a lot of little tweaks to get it to import correctly. So to look at that help page, I put my cursor down here in the console in the lower left and type a question mark and then read.table. And you'll see it gives us some options for autocomplete. And then I hit enter down there. And what I get over here is the help page. Now hopefully you're on a bigger computer screen than I am, and so you don't have to scroll around. I'll just rearrange my RStudio for a little bit. And so we see read table and then the parentheses like we would see for any function we use. And then we see this big list of what are called arguments, which are different things that you can pass to this function to control how it behaves. Now you'll notice the first one is called file, and that's the name of your file. Actually, if I can scroll down, I get the description of everything. And this actually is a pretty long description for what you can put in here, but if I look at the beginning of it, the name of the data, the file where the data are to be read from. So I know that the first thing I can give it there is my file. Right, because that's where I've stored this file name. Now I look at all the others, I don't have to type anything for those. This one was mandatory, and I could tell that because there was no equals sign after it. All of these ones with equals signs are optional arguments. If you don't edit them, they're going to stay at this default value that's shown. So for example, I'll say, okay, what's the header mean? And says, logical value indicating whether the file contains the names of the variables in its first line. Well, actually for me it was in the 13th line, but I still do want to keep those variable names. So I am going to change this from false to true. And it's important that when you type true, you put it in all caps. Right? Everything in R is going to be case sensitive. All right, the next argument I see is called SEP. So I can go down and take a look. What does that mean? The field separator character. Values on each line are separated by this character. So the default is actually no character at all, which it will look at any white space character. But because I know that my VCF format is tab delimited, I can tell it that it only separate things out for a tab. So I put a comma after my header equals true, then type SEP equals, and then quotes. And then what I'm going to type to indicate a tab character, I'm not just going to hit tab. Actually, if I try hitting tab, it tries to autocomplete for me. What I do is type a backslash and then a lowercase t. And that indicates the tab character without me actually having to type a tab. All right, so what else am I going to want to change here? All right, decimal is a period. We don't actually have any quotes in here, but I think I can leave that as the default. Let me see. So skip equals 0. That's one that I do care about. So if I look down, what is skip? So the number of lines in the data to skip before beginning to read the data. So you'll remember we had our 12 header lines before we actually had the column headers. So we want to skip all of those because they're not spreadsheet-like row column data. We might want to import them separately into a different object in R. For example, I could say my header, and then I could steal this read lines, and that was just the first 12. So if I do Control Enter to run that, now I have this actually now is an object that I could do something with. I can look and it's showing me what's in each of those lines. So now, that way I've saved that. But if I want to do something with rows and columns, it's going to be in a separate variable or a separate object. In fact, I'm setting up my read table command here, but right now that's not getting saved to anything. So let me do that here too. I'll just call it my data. All my variables here, I'm starting them with my. That's just my own little convention to show that it's a variable and not a command, but you can call these anything that you want to. Okay, so anyway, getting back to skip, and I made a line break there. R will ignore that line break. I just put a line break to make it easier to read. So I'm going to say skip equals 12 to skip those first 12 lines. Now the 13th line, as you recall, or you probably didn't look at it that closely, but I get up here and it also starts with a pound sign. All of these up here started with 2 pound signs, and this header row starts with 1. But I might, if I look around, let me see, there was one argument called comment character. Yeah, right here. So a character vector of length 1 containing a single character or an empty string. So by default, what it has here is the pound sign, and that means a lot like this script. if it goes into my data file and sees anything that starts with a £, it's going to assume it can ignore it. But I don't really want to ignore this because this is my column headers. So I'm going to change that to nothing to tell it to turn off comments. So all I typed was 2 quotes and I didn't put anything in between those quotes. All right. Another thing, and I mentioned this in my other video, but you'll almost always want to change the stringsAsFactors argument. And you'll notice there's a little bit of inconsistency in how these are called. So like this one uses a period to separate 2 words. This one uses what we call camel case. So you just have to roll with it and use it exactly as it's written here. So I'm going to have you take me on faith a little bit that you almost always want to set stringsAsFactors equals false, unless you know that everything that is a character, everything that is text in your file is something that you want to treat as a categorical variable for linear regression. Otherwise, you want to actually treat it as text, so you set this argument to false. So now I want you to pause the video and spend a few minutes with this help file learning more about read.table. In particular, for this exercise, take a look at what this quote argument does, as well as this na.strings argument, and try to think of cases where you would want to use one of those. So take a few minutes, look at that, and then we'll talk about it when you get back. Welcome back. I hope you took a few minutes to look at those arguments and think about them. Now to demonstrate what they're for, I'm going to make another little dummy file that we can look at. So I'm going to do that in Excel. If you don't have Excel, don't worry about following along. This is just a quick demonstration. So let's make a little table of different kinds of plants. So I have the plant, species name, number of seeds available. So let's say tomato, and that's Solanum lycopersicum. And why I hesitated a moment before is I also wanted to put in its older species name. There's Lycopersicum esculentum, before they decided that really it should be in the same genus as nightshades and peppers and everything. And let's say I mark down that I have 400 seeds available. And then say wheat is Triticum avestum. And let's say I don't know how many seeds are available, so I type something like unknown. Right, and I'm going to save this, and we'll browse to this same folder that I am using for my project right now. And I'm going to save it as a CSV file. We'll just call it plants.csv. Okay, so if I go back to R, let's preview what that file looks like as plain text. So we have it in Excel, but really on our computer, because we saved it as a CSV format, that is going to be plain text format. Okay, and I should be able to see it over here. There it is. Yep. And I'll put the name in quotes. And I'm not going to give a number to read lines, because if I don't provide a number of lines, it will just read all of them. And I know this is a short enough file that I can do that. So if I do that preview, I see that I have my 3 column names separated by commas. So CSV stands for comma separated values. But I noticed that when I have my species names for tomato, because I put 2 of them separated by a comma, they're in quotes. And the quotes indicate that this comma should be ignored. Like it's not a delimiter character, it's actually part of this string. So anything within quotes is going to be assumed to be part of one field and not part of a delimiter. Right, and I see my unknown there that I put for that. So if I look at quote, the default for quote, it might look a little funny. There's this backslash quote, which kind of like the backslash T that indicates that really I want this quote character, because if I just put a quote within quotes, it would assume that was the closing quote, right? And then it also lists a single quote as being okay for a quote. So actually, for this one, I can leave that at the default because it's going to see these quotes and it's going to know to treat that as one string. Now the na.strings is telling me what should I look at, or what values are going to indicate missing data. So by default, na means missing data. But I might also want to indicate that this unknown means missing data. So let's make a read table command for that. So I'm going to say header equals true, because I did put in a header. The separator now is a comma. Oops. Let me just type that quote there. Right, so I have the comma inside quotes to say that's my separator character, and then I have a comma after to say, okay, I'm going to go on to the next argument now. And we might say na.strings equals unknown. And so I'll put my cursor there and then press run to run it. And actually, if I just click on this, I can get a preview right now. And so where I had written an unknown, it replaces it with this NA. The way it's showing it kind of in italics grayed out here, that indicates that that's a special value indicating missing data. So NA means missing data in R. Right, and then I can see that correctly these 2 names went into one cell even though there's a comma between them. And these quotes are gone now. Right, what if I didn't want there to be quotes? So if I say there's really no quoting in this file, I'm guessing that's going to give me an error, right? Because the second line now, instead of having 4 values, it has 5 values, right? So, wait, let's see. 4 elements. Well, I'm not sure why it's saying 4, because here it should be 3 columns, right? And now this is getting split into 4 because it's splitting on this comma now. Now, if I looked back at the data that I was using down here, nothing was in quotes. So up here I could safely set quote equals nothing. To say if I do see a quote character, that is actually part of the text string that I want to import. But for this one, we'll leave it at the default so that it knows that quotes indicate one single value that goes in one field. Alright, so what we can do now is we can actually run this command and import the data set. So I'm going to hit Control-Enter on that line, and it runs pretty fast, and like I did with my dummy data, I can click on it to get a preview. This will take a few minutes because this has quite a lot of columns. If I look here, it says 99 observations, so that means 99 rows, and the 594 variables means 594 columns. You'll also notice, so we had that line that started with the £sign or hashtag Chrome, and you'll notice it's been replaced with x dot, and that's basically just because if we tried to work with a variable that had a £sign or a hash symbol in it, that's going to cause all sorts of problems because in R that's a comment character. So we'd have to do a lot of working around. So this is just changing all of the names to be something that will work okay in R. Likewise, if we look at our dummy data, it replaced the spaces with the periods because we can't have a space inside a variable name. There actually is an argument to turn that off. I believe it's check names. So if you really wanted the column names to be imported exactly as they are, I believe you can set that to false. Let's look at the description quick to confirm that. If true, the names in the data frame are checked to ensure that they are valid variable names. Yeah, so if we set that to false, then it won't change those. So something else that I recommend doing whenever you import data is a function called str. So let's look at the dummy data first. So str function, parentheses, like we have after any function call, and then dummy data will be the argument that we pass to that function. Control Enter to run it, and it tells me this is a data frame. Actually, both of these things are data frame. That's sort of the standard two-dimensional data format in R when you have rows and columns. It tells me what it told me up there, where I have 2 observations, 3 variables. And in this case, the most useful thing is that I can check what format each column is in. And actually here, because I forgot to set stringsAsFactors equals false, it is telling me that these first 2 are factors and have 2 levels, which mean they have 2 unique values. But then the other really important thing here is that it tells me that the seeds available column is an integer. That's what this int stands for. If you have a decimal number column, it will probably say num for numeric. So it's really important if you're expecting something to be integer or numeric and it's not, it comes up as factor or character, then you need to check your data carefully to see what else is in there. Maybe you need to set na.strings to some other value or something like that. I can change a little bit about how I import this to show you how that would change. So if I do add in my stringsAsFactors equals false, like this, now if I rerun str, it says that these 2 columns, plant and species name, now are characters rather than factors. And I still have integer for seeds available. If I don't do the na.strings argument, so here I'm going to do what's called commenting it out. So I'll put a comment character in front of that, and that means that line will be ignored when I run the command. Now if I look, I see that all 3 of these are characters. Because one thing here was text, it treats everything as text. So this is something you want to be especially careful of if you're importing numbers, to make sure they really get imported as numbers. So I'm just going to fix that and then run it again to correct it. So now I'd like you to pause the video for a few minutes and either try your own data set or make a little dummy data set in Excel like I just did. Import it with read.table and then check with str to make sure that every column imported in the correct format. And if it didn't, go back and see if there's something that you can change to make it import the way you want. So let's take a look at the larger data set, our genotype data set that's in the VCF format. So if I run that, I get a whole lot of information. In fact, it says list output truncated because I have almost 600 columns, and it's trying to show me information about all of them, but there's, more than most people would want to print out, so it stops printing. But if I scroll up far enough, I can see that my chromosome and my alignment position imported as integers. And then everything after that imported as text because it couldn't clearly be interpreted as a number. Okay, so if you've gotten everything you want to get out of this video, I give you permission to stop watching now, and I recommend going on to the next video called Exploring a Data Frame, which I'll link to in the description. Now I'm going to do a little bit more in this video. As you'll notice, a lot of the bulk of this VCF file is what kind of looks like gobbledygook, and we'll probably want to do some more processing on it. So I'm going to demonstrate how I would do that, which involves a little bit more advanced work, and it may or may not apply to what you're doing. But if you want to get a little bit of taste of text processing and some other things, feel free to keep watching. So one of the first things I want to point out is that we have these first few columns with some metadata about each one of these genetic markers. And after that, the columns starting after this format column, there's these columns with all these other names. And these are names of individual plants that were in this study. So it's information about the genotypes of those plants at those markers. So all the rest of the data is like that. And so all of these other columns are going to be in the same format. So when you have a whole bunch of columns in the same format, actually data frame is not really the most efficient way to process it in R because they're all being treated as completely separate variables, which might have different units or be in a different format. So what we would want to use instead for that would be a matrix. So I'm going to make a matrix and I'm going to call it my geno for genotypes, and then as.matrix to convert part of this data frame into a matrix. And so I'm going to put in my data, right, because I want to take that data frame and convert it to a matrix. But I don't want to take the whole thing, I just want to take it starting after this format column. So how many columns is that? So 1, 2, 3, 4, 5, after alts, qual is 6, 7, 8, 9. So starting at the 10th column, we get our KMS 207 and then other individuals. So let's say 10 and then a colon, and we'll go all the way to the end. So the last variable is number 594. And as I like to do, I'm going to double check this before I do it. So I can get column names from my data frame or from a matrix using the call names function. So let's see what the first 9 of those are. Right, so that goes from chromosome up to format. And then let's look at, say the next 5 of them. Right, that's where we start getting individual names. So I'm going to convert this to a matrix. Right, and then if I look and see what I got out of that, it's now it looks a little bit different from the data frame that we had before. See, this instead of saying that this is a data frame, it says it's a CHR format, and then these are the dimensions. So 99 rows, as we had before, 585 columns, because we eliminated 9 of them. And then a little preview of what's in there. And we also have div names. So the first one is row names, which is null right now because we didn't have any row names for this data frame. And then the second one is the column names. So I could add row names. And so up here I use column names to extract columns and take a look at them. Here I can actually assign something to the column name, to the row names, excuse me. And so I'm going to, let's say there's an ID for each genetic marker, and so it makes sense for that to be the column names. So I could extract the ID like this, right, similarly to what I did up here, or, which is a little bit more robust and readable, I can extract a single column using the $sign and then the column name. So let's do that again and see what we get from str. So now we have both row names and column names. All right, and one way I can preview is by clicking on it and viewing it up here. I can also, sometimes it's just like, oh, let's look at the first 10 rows and columns, and this will run a little bit faster, right? And so now I see the names and I see what data is in each of those cells. Okay, and this is going to make it a lot easier to process these all at once because they're all in the same format, right? And so whatever we do to them, we can do to the whole thing at once now. Now you may or may not be familiar with VCF format, but this bit here before the first colon represents the actual genotype. So the period means missing data. We've got a lot of missing data here. This 1/1 means it's a homozygote for the second allele, which is labeled as allele 1. We've got another 1/1 right here. 0/0 means it's a homozygote for the first allele. And we may or may not have any, we don't have, in this little preview, we don't have any 0/1. But if we had 0/1 or 1/0, that would indicate it was a heterozygote. And so all of this other information after that colon is various quality information, information on how we got those genotypes. So let's pretend that we want to ignore all of that and just get the first bit. So there are a couple ways to do that processing. So one way is a function called stringssplit, or strsplit. Right, so this can split up a string based on a particular split character, kind of like we had the sep argument for read.table to tell it, the tab should be the separator or a comma should be a separator. We can say that we want to split these individual text values based on some character. In this case, that would be the colon. So let's do a quick test of that. So let's just take, say, the first 10 values of that first column. And I'll delete that to say column 1. So this bit first is the rows, and then after the comma, that's the columns. And then we'll say split equals colon. And if you're a little new to R, this would also work just fine if I just put a colon there, because that would be the same argument order. I like to have the split in there for readability. It will work either way. So if I preview that and see what I get, I see now for each of those values it has split it up. Right, and we get what's called a list. So each item in the list is something called a vector, which has each of the items that was split apart. Right, and I'm getting a little bit advanced in here, but this is, just for your edification and sort of learning, something to follow along with, and maybe you'll learn more in the future from some of the other videos we have. Yeah, what do I get if I do the first 2 columns? So then, yeah, now it's just numbered rather than being named by the row, but it's going to go basically down the first column and then down the second column. All right. So, but what I want is just the first item out of each of these. So I can do that with something called sapply. So that will take this list and then apply a function across it. So I can define that function in place. Again, don't freak out if this is your first video and this is very confusing. That I'll as I make other videos that explain this, I'll put the links to them in here. So if I do that, now I just get the first element of each of these. Right, so now I've kind of cleaned it up to just the information that I want. But you'll notice it's no longer in a matrix. We need to put it back into a matrix. So let's call that matrix mygeno2. And here we're using the matrix function rather than the asMatrix function because we're creating a matrix from scratch rather than converting a data frame to a matrix. So I'm going to take this sapply command that I just developed and tested out. I'm going to do it to the entirety of my geno. And then otherwise for the matrix, I need to tell it how many rows and columns. So I can just say, okay, we want to match everything from my geno. So the number of rows is the number of rows from my geno. The number of columns is the number of columns from my geno. Yeah, let's put a line break there. And for the row and column names, we can use something called dim names. That will get both the rows and column names at once rather than one at a time. Right. It's giving me a little warning, but sometimes that just takes a moment to go away. Okay. So if I run that, now I can get a preview of what came out of that. Right, and now I just have that data that I wanted. All right, so let's pause the video just to wake up for a minute and make sure you're following along at least a little bit. So say instead of this first part 0/0, I wanted to capture this second part where it says 2/0, 2,0 or 0,0 for these various ones. How would I change this command to do that? So spend a minute playing around with it and see if you can get that. All right, welcome back. So as you may have guessed, there's not a whole lot to change here. So if I change this right here from 1 to 2, and then say I wanted to preview it to see if it worked. Right, okay, now that looks right. I get this, these pairs of numbers with a comma in between them like I was seeing in that second field. Right, so if I go back and look at this string split, all right, it's the second thing that I was trying to get this time. And so instead of making this function that extracts the first element out of every vector, I'm making a function that extracts the second element out of every vector. Now let's say maybe I want to convert that to numbers. It's very common to use 0, 1, and 2 for marker genotypes. So like 0 indicates homozygote for the first allele, like this 0/0. 2 indicates homozygote for the second allele, like this 1/1, and then 1 would indicate a heterozygote. So I could actually set up another matrix for that. Let's call this myGeno_num to show that it's now actually going to be numeric. So we're going to set up a matrix and we're going to start out by filling it with missing data. But then otherwise, we're going to give it all the dimensions and names of our genotype matrix. So if I look at that right now, right, it's all missing right now. But I can fill it in one item at a time. So let's say where my geno 2 is equal to 0/0, we're going to put in the value 0. Oop. Where my geno 2 is equal to 0/1, I'm going to put in a 1. And I think it's possible to have a 1/0, so I'll put in that one as well. And then I'll just copy and paste this and edit it one last time. So if we have 1/1, that'll be 2, and we won't bother filling in where we had all these periods because that's missing data anyway, and that's how we initialized our matrix. So now if I look at that, now I have my numbers filled in. And let's even take a closer look at that so we can, or look at the whole thing so we can browse through it. Which again, yeah, it's a little slow just because it has a lot of columns. All right, so a lot of missing data here, but then as I get down to some other markers, I've got a lot of zeros and ones and twos. Right, so now I have numbers, right, which is great if I want to do things like math. So for example, now I could get allele frequencies from this data. So if you're not a biologist, an allele frequency means how common is this allele in the population? Like out of all copies of this gene, how frequently do we see this particular allele? Technically, these aren't genes, these are just nucleotide locations like a particular letter in the genome. So for that, so every genetic marker is one row, right? So I can do something called row means, and that will get me a mean value for each row. And because there's a lot of missing data, I'm going to say na.rm equals true, and that will get me the mean ignoring any missing data. And because this is on a scale of 0 to 2, and I want it on a scale of 0 to 1, I'm going to divide by 2. And lastly, I'm going to assign that to an object so I could do some more analysis of it. So if I run that, I can say, let's look at the first 20 of these. Right, and I see I have a value for each one of these markers. Right, and I could even do a histogram to see how they were distributed. Okay, so I did that initial text processing using strsplit and then using sapply to just take the first value out of the split. If you want to do some other types of text processing, there are other functions you can use. So one is substring. Right, so this is if you know the starting and stopping position of the text that you want. Say, for example, I had the text apple and banana, and I put that inside this C to put those together into one, basically into one variable, or like one column of a data frame. And I want to start at position 1 and end at position 3. I put in position 2. So position 3, right, then that gets me the first 3, whereas 1 to 2 got me the first 2. Right, so if you have a reliable number of characters, and you know exactly what positions you want to extract, you can do it that way. Another way I could have manipulated this is using something called gsub. To substitute, and grep is a related one for searching for particular text strings. There'll be a whole other video on text processing, so don't sweat it too much, but this is a little bit of a preview. Right, so for example, instead of this sort of compound thing where I did sapply to a string split, I could do a gsub instead, or technically a sub, since gsub replaces multiple times, sub only replaces once. So I want to substitute everything after a colon. And this is, if you aren't familiar with regular expressions, you're like, Lindsay, what the heck did you just type? So let's see. If you want to learn more about why the heck I just typed that and how this means the entire string after a colon, look at regular expressions, or better yet, Google regular expressions, and it will explain what that all means and how to construct these. So I want to take the first colon and everything after it, and I want to replace it with nothing, right? Which basically means deleting it. And the thing that I want to replace it out of will be the my_genome. And again, let's, I don't have to redo the whole thing, but I can redo a little test of it. Right, and so now, no, not genome, no, I'm sorry, I made genome 2. Right, and now I get, again, oh, and this one keeps it as a matrix, so this would probably have been the better one to work with to begin with. It just requires a little bit more understanding of what this regular expression means. Right, okay, so I'll link to some additional videos as I make them that might be more helpful for this sort of thing. But I hope this gives you a preview of the kind of data manipulation that you can do in R.